Well, here we are back at the repair bench. No surprises there. Today we're going to look at a missile command board and hopefully get it booting up again. So this is one from a cocktail table version, which belongs to Andy from Arcade Club. Hopefully I can get that out on the floor very quickly for them. The machine was delivered with a board fault. Board is complete, very simple to work on. Well, I say simple, it always sounds more simple than what it actually is. It's a 6502 base CPU. There's a pokey over here, which is Atari's custom sound generator and potentiometer reader and random number generator and all sorts of other bits and pieces it can do. There's a block of RAM over here. Then you've got some output logic up this end. We'll not delve into that too much. Oh, sorry. And also you've got a bank of EEPROMs and stuff here. So the board is watchdogging at the moment. I've got it all hooked up on the bench, and if I go like that and switch it on, you can see garbage on the screen, like so. And if I put my scope probe on the reset pin and you look there, you'll see that it's rebooting like crazy. If I can do it, what I'll do is I will just try and, very, very difficult to do one-handed this, but I should try and do hold a reset condition at the same time. So I'm holding, oh, that's like the reset button itself isn't actually having any effect, and it should do. So we can see that the watchdog is toggling, which means that it probably can't read RAM and ROM. We're not going to waste any time here. Oh, sorry, the last thing, the other thing I'll just double check is the clock on it. 39, 38, 37, pin 37 on a 6502 CPU, which is that one there. And we've got a clock signal, and it measures at 3 and a bit megahertz. It's oscillating very slightly, but that's because I'm zoomed into hell on the scope. Let me just see if I can fix that. So I'll just try and zoom out to hell and back. Let's have a look. $37. Oh, too far. There you go. There's a nice stable clock signal, and it's oscillating at around about 3 megahertz, and some of that is probably the reset that's kicking in on it. If I ground the watchdog out, that will go stable, but that's a nice stable clock. In fact, you can see in time with the watchdog resetting, if you look there, I wish I had two cameras to do this. If you look at that bottom left hand corner scope, you'll see that with the flickering of the screen with the watchdog reset, there you go, it quite happily keeps flicking with it. Alright, so that's why the frequency counter on the scope is saying it's not an exact clock frequency, but I'll forgive that. So one of the other things that Atari give you on these boards is a whole bunch of test points. I've tested the 5 volt lines, so what I'm going to do is I'm going to test the read-write signal, and that's good. Yep, I've got activity there. And I'll test the clock theta 2, which is generated by the CPU on pin 39. That's all good. What other test points? Well, we know VSYNC and HSync are working, otherwise we would have an absolutely screwed up screen. I mean, I know that's garbage, but it's static garbage, and that's a good thing. And we know why it's doing it. There's not really a lot more I can sort of poke around. I've checked the voltages already. That's the first thing you ever do with these boards. Right, well, I think to save some time, what we're going to do is we're going to throw our friend the Fluke 6502A pod at it and see what's going on. So I'm going to take the CPU out, stick the pod in, and do some RAM-ROM tests on the Fluke, which I've got set up over there already, because this will save a lot of time by doing it. I attached the Fluke pod to it, and then it occurred to me, I can't really verify the ROMs via the Fluke unless I know which ROM set that I'm dealing with. So I did a bus test on it and things like that, and that was all okay. So I thought, right, well, now it's time to pull the ROMs out and check them all. Unfortunately, this one here, a number of the legs were already broken off it when I got it out of the socket. They were actually disintegrated and had come away. So that's one that definitely never would work. There's no doubt about that. These are a 2716 type EEPROM, which is 2048 by 8 bits. So I need to go and find a 2716 EEPROM, erase it and program it and put it in there, and then I can start to do bus tests and read-write tests on the data bus. Right, I have some EEPROMs up, some 2716s up here in the EEPROM eraser, quite happily clearing themselves off, and I've got the Fluke all now fired up, and I'm just doing a straightforward run. Of course, it's not going to run. Now, what can I say? It's not going to run without, I mean, that should actually be the boot ROM there, which is the R1. That goes in the later half of the memory. 6502's boot vector is FFFF, so therefore it's waiting for things up in the upper memory region to happen. So, what I'm going to do is, I'm going to concentrate on why the address bus can or cannot read. I'm going to try and verify this ROM2. Now, I know it's revision 2. I have got, on here, I've got the Fluke signature for revision 2, which is 3977, and its ROM offset, which is 5800. So I'm going to do a ROM test on here. So ROM test at 5800 to 5FFF, and it's 3977 is its signature apparently, and I'm going to run it. Now it seems to sort of go through, so it must trigger something on the CPU line which causes a screen reset to happen. First time I've played around with the 6502. Now it's beeping at me and telling me that there's a problem, and it says press more. So it doesn't like what I'm doing, so press more, and it says the signature it got back was 5CD7 and not 3977. Okay, so I know that the ROM is absolutely fine because I've verified it. So all that can be problematic now is either talking to that ROM, as in address logic to get to it, or the buffer drivers. And given my previous experience with my own missile command board, I'm going to look at the buffer. I'm going to look at the line drivers for it first. What a good way to test this is if you get a hex dump version of the EEPROM up, and this is that particular ROM at JK1, and you should notice that byte 0 of the ROM is 25 followed by 09. So what I'm going to try and do is just do a straightforward read. So if I do read 5800, what I should get, I'm getting FF. Now that tells me either the ROM position isn't toggling, or the data line drivers are knackered basically, and it's never clocking across from one side to the other. So the CPU is receiving just ones basically. Let's try reading 5801, 5801, because this will. Yeah, well, 5804, that's still FF, 5801, nope, I'm getting FFs everywhere. Now this tells me then that basically the line drivers are stuck and probably completely knackered, or the chip select's not working. I'm going to look on the schematic in a second, and I've got that, I think it's, where's the PDF? There it is. Right, so here's the program ROM section, and what I'm going to do is I'm going to follow back the chip selects first, and just make sure that the chip select for that particular, that EEPROM there, is definitely getting pulled low when it needs to be. So that's going to be me next. Okay, set up now. I'm doing a looped read of 5800, which is where this ROM that I'm on is. I have got the probe on the chip select, or chip enable, CECS, interchangeable term, and it's constantly high. Okay, no activity. Oh, it's time for a quick trace back then, so it's the next chip backwards and then find out what's going on. I should definitely have addressing coming out the bus, so I've got to follow the program, the address decoding chain, because if without anything going there, that is when you will get definitely FFs on the bus. So I've got to solve that one first. Got to get the chips to be readable before I can go anywhere. And again, that could be a buffer driver, so a 244 or 245 that's dead and not passing data across from the address, the CPU address bus onto the main game address bus. Let's have a look. Investigation continues. What I've done is I've put a couple of markers on some chips. So this one is basically just the next step back from the EEPROM chip selects. and this one is the one just before that. And then what I've done is I've come back over here, and this one up here, N2, which is this one, is a decoder chip. Now what I'm seeing is basically signals not being driven low enough. So I've gone backwards through all that and landed at where I suspect I was likely to land, at a buffer chip, a 244. And what I'm going to show you is, and just excuse me whilst I get this on the right pin, 876 there. So that's an input, and that is a select, an address going low from, if that's pin 6, from A10 up there, A10 pin 6, and that's its input there. Now let me show you its output. Its output for pin 6 should be pin 16. Okay, so let's find pin 16. 18, 17, 16. There's 6. There. Oh, sorry, I managed to short a pin out on the Fluke. I'll restart that. Read 5800 in loop mode. Okay, find pin 16 again. Sorry, it's not pin 16, it's pin 14. I do apologise. 14. Let me find 14. 12, 13. There's 14. So there's the opposing output for pin 6. So I'll show you 8 now. I've found something interesting. 8. And there's your input. Now, that kind of screams at me that there's a problem with this chip. Either that or the CPU. And either way, the next device back in line from there is the CPU. And I've traced the line, and it comes straight from this pin here, pin 20, which is generating that signal. So what I'm going to do is, that 244 has got to come out, I think, at this point. I don't trust it. I suspect some kind of weird problem with it. I think you've got shorts stuck, etc. Time for it to come out. Once it's out, I can put the thing back on and see if I got the same thing I shouldn't have. Basically, the reason why this whole lot isn't working is because the line pulses just aren't going low enough to actually be a low signal, so it can't detect the falling edge and actually do the job it's supposed to. So I suspect, as I kind of made a guess before I started on this board in my head, it's going to be somewhere around these 244s. Now I actually counted all the pins on this first one down here at AB1, which is this one, and that one was absolutely fine. Now if I can't get addressing and select through, I can never get anything back on the data, so I've got to get the output towards all the data to work before I can expect any input to work. Let's yank this 244 out here, and we'll see what we've got then coming off the address lines on the CPU. I should hopefully have a better signal here on pin 20, because that's a pile of crap. Don't want that. I want something better than that. What I should see, let's see if I can find another pin. 19. So if I go to the one before it, 19, that's what I should see. That is a proper clock cycle pulse, that. Now it's pulsing because the Fluke is continuously reading. So that's a wide enough pulse, but if I go back over to this one, that's not. It's been pulled high. And the only other thing I can think of that could possibly be controlling this is I've got some markers on here, and I'm not sure whether they're pull up or pull down resistors. They basically are supposed to assert the data line, and the data line is supposed to drive low. I think that it's very rare that pull-ups or pull-downs. I'm pretty convinced that that's what they are. I've seen this kind of configuration before. I just can't find them on the find a note about them on the schematic, so I'm going to have to do a bit of digging on there, but I suspect they're pull-ups. Let's yank that 244 out. That 244 was removed from the circuit, and I've tested it and put it back in because it's absolutely fine. I have checked now the next thing in sequence, and everything seems to be behaving as it should be, up as far as this 7442 that's sat here. And I've got the comparator on it over here, and it's saying that pin 9 is bad. Now, at the moment, what I'm doing is I'm reading a different memory address. I'm reading 6800. What I'm going to do now is, you can't see me do this, but I'm going to type in 5800. Okay, and hit go. Oh, look, you see one of the things disagree. and hit loop, and I suddenly get pin 6. Pin 6 is, according to the schematic up here on that decoder, that is actually prog cell 0, which can't seem to go low properly. So what we're going to do is going to lift that out and we're going to test it out of circuit, and the comparator tends not to lie. I'm going to trust it that if it's doing that and it's changing when I change what I'm reading from it, then it's going to say it's bad. Now, I don't have any 42s on stock. Fortunately, I do have another board, and that has a socketed 42 on it. So I'm just going to lift that out, test that as well. If that's good, then I'm going to socket that position on the board, and then drop that 42 in it just to test it. I've already placed an order for some, so that's the next step. 7442 has now been replaced with a temporary in a socket over there. We've got the game board all set up with the pod back on it and with the thing booted up. So what we're going to do is going to do a read at 5800, see what happens. Nah, now that's what I expect. I'm certain this is. Let me have a look on here. I'll wake the screen up. If I go back now into the, where's the, there we go. No, there it is. I'm not sure which ROM I've actually got open here. Read from device. I don't think it really matters. Let me reopen what should be KJ1. Missile command. All files. So what I want to do is load up the JK one, which is that one, and put it in there. Ah, that's a good sign. So the first item in 5800 is 25. Let's have a look at 5801. So read 5801. Now it's coming up D9 now. Oh, and that is actually correct. Let's have a look at 5802. I think that says 85. 5802. 85. Okay, so I think what we're going to do now is going to go for a ROM check. Sorry, zoom out. Wrong way. I think what we'll do is a ROM check. So let's see if we can read anything from the start of any of the ones. Yeah, that's better. We're not getting FF anymore. There, 5. So we've done 58. 6000. That's good. Read 6800. 06. And read 7000, 20, and read 7800. So the main thing is they're not coming back with just FF. So what we do now is, on here, we go to our Fluke signatures, and we do a ROM check from 5000. So ROM test at 5002, and the other address is 57FF, 57FF. Oop. Typed it wrong. 5. It's a very awkward keyboard. 57FF. Enter. And the signature is 3A1F. So 3A1F. So I'm punching that in. I'm going to read from 5000 to 5700 FF with 3A1F. Okay, and I'm going to go. I'm going to say wait, and the screen's flashing like crazy, so something must be tied to RAM-ROM there, and it says that one's okay, so that's ROM 0 okay. So I'm just going to do the same thing now, so I'll do a ROM test. 5800 to 5FFF. Signature according to the screen is FE9F, so FE9F. Let's go for that. Not sure why the screen's flashing like crazy there. Reminds me of Commodore 64 loaders. Ah! So ROM error. 5800 to 5FFF. Doesn't like it. It's saying 3977, not FE9F. So am I looking at the wrong ROM set here? So let me go back into, so the signature came back with 3977. Ah! So it looks like this is actually set 1 that I've got here, not set 2. because the signatures for the two... I'm just looking at the ROM signatures that I've got over here. Sorry, I forgot to put the camera on the screen. So basically, what it looks like is... of course, they will come... yeah, I understand. Okay, so basically in the main ROM set, which is what these drivers are talking about, the revision 1 ROM set, all these ROMs are stamped 02 on them, the originally ROMs, which means set revision 2 basically. So yeah, 835.02. Yeah, those were actually what they were listed as. I'm certain that's what they were listed as. You know what? I'm just going to pause the camera just for a second, whilst I just use both hands and eyes for something. Right, so that's the ROM that was in the H1 position, 03. I'm going to get it to focus, 035820-02. When I look at the screen up here for the Fluke signatures, 035820.02. So I've written, I see what I've done, I've burnt the wrong EEPROM. Okay, well that's no problem, I can fix that. That's quite easy. Let's proceed now. So we know we've got effectively missile command set 1, not set 2 in this board. So what we'll do now is we'll proceed to ROM check, and we know that 3977 here is what we got for ROM 2. I'm going to run it again because I want to make sure that it did what it was supposed to do. So 58002 5FFF, and the signature according to there is 3977 3977. Go, read. And that says OK now. This is good. So let's read the next one. So the next one down the list is 6067FF. So read 60267FF. Signature is E850. E850. And we're running. It's only 2K, it only takes a second or two for it to run. Yeah, that says OK as well. So we're going to do a ROM. Next lot is 6800 to 6FFF. So 68002 6FFF. Signature over here 6800 to 6FFF. EF62. So EF62. Let's have that run. I'm doing most of this in real time. EF62. That one's okay, that's good. Next one is 7007FFF. 77FF with a signature of B25D. B25D. Go. I was going to say OK, and then last bit of ROM is going to be 038, that one, yeah. So 7800 to 777FFF. Let's do that. 78000 to 7FFF with a signature of B888. That's an unusual one. B888. Go. Now this is going to work or it's not going to work. That's good. So now it's saying that all my ROMs are now good. So let's see if I can touch anything on RAM. So I've got some RAM locations over here. Apparently I can write from... Let's do a RAM test from 0 to 18FFF. So RAM short, I don't know what's going to happen here. 18FF. Nope, BTS 40. So you can't write to. It's interesting what you can read and write to on RAM over on these things. Let's try 400. So yeah. I see. It's telling me where I have got some RAM. 1900 to FFFF9. That's. It's got some work RAM somewhere, is this thing? 405 FFF. It won't be much. Let's do a RAM short. 400 5FF. Yeah. Okay, so the RAM is kind of a little bit confusing as the memory map on here. It should be. It's either. What I'm going to do is I'm going to do some manual read-write operations and come back. But the main thing is now we've got all the ROMs readable. So that's half the battle. The next thing is the... Can I access this block of two 4116s here? If I can, then realistically the game should start booting up at that point. Well, I knew I'd seen one. And Atari games always seem to carry a memory map. So what I found is that there's some work RAM, which is 000 to 01FF, is some 512 bytes of working RAM. Okay, fair enough. So what we'll do is do a write into that location. So first of all, let's see if we can clear it. So write into 0000 00. Now it says it's okay. When I go to read, no, what do we get back? 44. We should get 00 back. Let's try right. No. Let's try something like 88. Okay, read. No. Alright, yeah, so we definitely got bit 4 in each nibble, which is permanently set to on. Okay, so I've got to look at the program RAM, the DRAM circuit for it, and see what's going on with that, because that will never let the game run whilst that's like that, because it can never talk reliably and read write from it. Investigation continues. Done a bit more digging, and it wasn't the 244 that I thought it was going to be over here. So what I'm seeing is basically bit 4 and both nibbles are on. So that's 1, 2, 4. So 4, 8, 16, 60, 4 and 64 are both on. So that's why I'm getting 44 everywhere. Now my initial suspicion was this 244 over here. Pulled and tested it, and it's absolutely fine. What I did find was that the data output bit, which is pin 413 on, so these RAMs, 2 of them in exactly the right positions were low. Unfortunate, and one of them was over here. I had a spare RAM for that, and then I put another spare RAM that I had in that one, and that one was actually unfortunately defective. So I'll have to get some 4116s before I can go any further with this. But I'm confident by swapping a few of these around and getting the bit patterns to change, and it's all lining up in the right place. So should get me a 4116 in there. Should solve most of the problems. Get some 42s into there, and this is actually a 42 in this makeshift thing. I looked on the other board. I don't want to start pulling RAMs off the other board because of the damage you can cause by heating and pulling them. And I don't seem to have any spares kicking around other than the 2 that I had. So I must get some 4116s. Alright, so let's... there's going to be a bit of a pause in time here, but in the video it's just going to be a quick cut between me going and getting some 4116s. It's in about 1 in the morning, so I'm over at the arcade tomorrow. I'm going to blag some 4116s off Andy. He says he's got tons of them. Time to cough up, my friend, if you want your board fixing. No, I'll grab some off him, and then I'll boost up my stocks over the next couple of weeks as well. What I will do though overnight is I will clear this EEPROM, which I know I burnt from the wrong set, and I will burn set 1's version of H1 and do it that way. And then I know that the signatures are all going to match, so there's definitely no discrepancies in program code across the entire ROM set, and we're all going to be good. couple of days have gone by now and we've now got some new RAMs in the sockets. In fact, what I've done is I've got a complete new set that match each other in there because that's supposed to be more reliable. What I'm going to do now is we're going to power the board on and we'll do a RAM test. So we've still got garbage on the screen, which is that's not that good a sign. Let's do a RAM test. So let's see if we can read and write from RAM. So write location 0. 0, 0. It says it's right. It's okay. Let's do a read. Oh no. Okay, well that's a good sign. We've got a read write of 0, 0. Let's do a RAM test. So RAM short. Let's tell it to not 01 FF, which is the first 512 bytes of RAM. It's interesting because you get a whole bunch of like flashy C64 style loader stuff going on. RAM tests in progress, and it says it's okay. Well, that's good. I've no stuck bits anymore, so why is it not booting? So I had to replace a chip over here, an LS7442 over here, which wasn't correct, which is to do with the ROM addressing. We've still got this breadboard thing over here that somebody had botched in. I think what we'll do next is we'll replace that. We've now got some 7442s on stock, so we'll replace that and see what happens next. That bodgy bit of breadboard version IC whatever, which is 138, has now been replaced with a 7442. Let's see what happens. Constant yellow screen. Sorry about the flickering from the camera. And we get a RAM test. And okay, so we've got ROM OK, map OK, and RAM OK, but we've got some corruption down in the bottom area of the screen where the cities would go. So what I'm going to do is I'm just going to take the test connector off. So the board should reset now, hopefully. Yep, auto reset, and we get missile command. So we've kind of part resurrected this. Okay, but what we've got is some crap going on at the bottom of the screen. Right, this is going to require some investigation to find out what the heck's going on with that. Well, right, what I've noticed then straight away is, so let's count. So how many bits in a byte? Well, we have 8. So 1, 2, 3, 4, 5, 6, 7. Aha, 7 socketed ROMs, and there's one RAMs, and there's one hiding its way behind here. Now I don't suspect that it's dead, but what I do suspect, and knowing some things that I know about Missile Command, is that the timing is possibly off between these lot. Looking at the schematic, it mentions that there's a signal called 3-col cell, which is 3-bit colour select, and it also makes a very specific note that 3-col select is used in the bottom 32 lines of the screen, the bottom 32 lines being where the cities are here. I'm not going to before I start chasing myself all around the houses on this board trying to find a problem that may not exist. I'm going to pull this RAM over here, this bottom RAM. I'm going to put a socket in. I'm going to put a brand new, exactly the same type of RAM as in here, because I can't see any other fault with the game other than if the RAM timings are off, you will get all sorts of weird stuff goes on. Missile Command and Pole Position have these weird RAM timing problems, and if you've got mismatched, and it's DRAMs anyway, so if you've got one block of RAM that's delivering one thing and another delivering another, then God knows what you could get. There's no issues on the rest of the screen, it's just in that 32 area, and you can actually see the cities themselves at the bottom, which is definitely a good sign. Right, let's pull that RAM and stick another one in. That last RAM has now been replaced, and I've put the board all back onto test, and unfortunately it hasn't cleared up the problem. So it was worth going through that process and lifting that one out and making sure they all match, just to check out what's going next. So I've got to look now around the 3-col cell and the bottom bit of the screen signal and see what's going on there, but that's definitely some kind of colour palette select jail stuck bit problem. Time to look at the schematic. Right, there's the Missile Command boot screen. I've just been having a bit of a poke around some of the data bus after the DRAMs and around the colour circuit and everything else, and so I've got a comparator on, and straight away I find this chip here, a 153. Just basically working my way up and down with the comparator and with the scope and things like that, and I'm seeing that on that I've got a stuck pin on it, pin 9. Pin 9 leads out into the data input for the input of the latch at S75 latch, so that can't be good. So as a precaution, what we'll do is we'll pull out that 153 and we'll socket it and we'll test it out of circuit and then pop a new one in. Right, I've replaced the 153 chip and I'm still getting the same sort of problems. What I've actually done is when I pulled the chip I discovered that it wasn't actually bad using a logic tester. So what I did is I looked at the chip it's next connected to, so that pin 9 goes to pin 7 on this S75 over here. I'm connected up to pin 7 there on the scope, and that's kind of floating. That would be enough to cause a discrepancy. Now I'm not saying that's the be all and the end all of the problem here, but it can't be far off something to do with it. So I'm going to lift out this S75 now and test that out of circuit. That's about the only thing I can do next. A couple of days have passed now. I've had a little bit of a break to do a few other things. The S75 chip was pulled and resocketed, and we've definitely got problems on that pin 7. I don't have any more S75s. I tried to pull one off another board that I'm working on next, and unfortunately one of the legs was already broken on that board, so I've had to order some S75s. However, I'm not quite convinced that it's part of this particular problem that we're seeing at the bottom of the screen. I think that's it doesn't seem to be in that exact circuit. I've done a little bit of reading around the net, and I don't think I'm kind of looking in the wrong place, but I think I'm looking in the wrong place for this. What we have here is this bit of the schematic called picture bit converter. Picture bit converter, we'll not go into too much depth on this, but basically you've got two sections of the screen. You've got the upper half of the screen, and then you've got the lower half of the screen. The lower half of the screen is powered by a signal called LD3 col. So what I've done is had a poke around, and I'm just trying to see this through the camera lens at the same time. So I've had a poke around, and what I spotted was on this 166 here is I have no signal. I have a 5 megahertz clock here at pin 1. I have a 3 INH signal, which is an inhibitor signal. Basically it says that for the last 32 lines of the screen it'll be in a particular state. And then I have an LD3 col. Now LD3 col needs to be pulsing, and it's not. So I've followed LD3 col back up here. So follow that line there and across here, and there's LD3 col source, and it's at this 175, and you'd think, straight away, oh, it's that 175, it must be that 175. So I've had a look at the input pins, the output pin. So that's definitely the same condition. It's not moving whatsoever. It's just, ground level. I had a look at the input pin. There's nothing coming on the input pin. What I had a look back here was at this here. So there's an LS32 chip here, and pin 13 and pin 12, which are its inputs. Now this is just a blind gate. It doesn't require any other clocking signals or anything like that. It basically has signal in at 13, because the 13 also goes to 12 there, and that signal is changing. And there's definitely a clock signal coming to here at pin 12, but there's nothing on this output. So what I'm just going to show you now real quick is that this particular chip in question is this one, C3. So I'm going to turn the board on, and I'm going to put my logic probe, my scope probe, on pin 13. It's a 14 pin chip, sorry, that chip there. There's pin 13. Okay, I'm going to move across one, pin 12. There's your pin 12, and I'll move across here to pin 11, and there's pin 11. That should be state changing. It should be massively state changing, because it can't do anything else but change state. If I just short the two pins together, the thing will invert and the whole game will come to a halt, because it uses that chip for other things anyway. So if I take another an S32 chip, chip. I had one a second ago on the bench here. Here it is. So I've got an LS32 here, which I'm going to just pop over. That one, piggyback it onto the back of it, like so. Just get that on. Difficult one-handed. And what I'll do is I'll switch on. Okay, so the game is now running, and here is my. I hope when this comes out and I go to the edit, then I can actually see that I've done this. So there's your pin 13. There is pin 12. Okay, now I'm going to show you pin 11. Can you see there's some fighting going on? There's a different state of signal completely on there now. Now I can't tell much on the screen because the signal's just not going up high enough for it to register as a logic high, but I can see the two try to fight it out. So next step, I'm going to replace that S32 chip. That 7432 has now been replaced there on the board in the corner. And let's moment of truth it. Confident this is going to fix at least that lower part of the screen. Yay, there we go. Right, now what you can see here is we've got some other colour issues going on here. So for example, your defend cities wording here and your missile beams coming up from the bases isn't quite right. Now I'm pretty convinced from doing some research on the net over the last couple of days whilst I've been on trains and out partying a little bit. If anybody caught my post on Saturday night, I was at Brewdog in Liverpool because we're going to a show with Colin. I think it's going to be somewhere around this 7475 down here that needs replacing. This issue seems to occur once the board's been on for a little bit, and if you notice, it's kind of like leaning towards its purple colour. I mean, it could be anything. It could be the 7475, it could be the 74125 next to it, or it could be the 82S25 RAM here quite easily. But I'm saying it's not the RAM because everything else is working on the screen, and that is basically 64, it's literally 64 bits. Is that RAM, and it's just being used as a scratch RAM for colour. I would imagine it's going to be something to do at 7475. Get that replaced, and I think that problem is going to more than likely go away. Well, at least I hope. And the ultimate test. Unfortunately, I don't have a trackball set up here on the bench. So what I'm going to do after this is all up and done and dusted is I'm going to stick it in my missile command cab and give it a thorough thrashing. But I can see that certainly the lower, when it comes back around, the lower 32 lines are absolutely fine. I can see the missiles, I can see the cities. Let's go back. So I can see the missile in the three bases, 2, 3. I can see the cities that are here, no problems. Something to do with the top half of the screen, so that's going to be around LD2 call and a few other things. So my suspicions of some potential issues on the RAM, on the data bus, are incorrect. I think I've probably lost a smoothing capacitor somewhere or other. It wouldn't surprise me around the DRAMs. So okay, so we'll wait for a 7475 to come in, which will be in the next day or two. This seems to be something to do with the red-green signal. So yeah, it wouldn't surprise me if it's not down that section. Right, the observant of you are going to say, hey, that colour problem seems to have been resolved now, and it all looks like it's all fine. Alright, well, looking down here at the board. So off camera, whilst I was waiting for some of the parts to arrive, I decided to have a poke around some of the chips, and I discovered that the PROM here at L6, some of the signals it was putting out on some of the pins were a little bit weird. So I decided to go and order up a couple of new PROMs as well from Mark at Retro Clinic, as well as an 82S25 replacement RAM 74289, and just test those out. And that worked absolutely perfectly. So that seems to have solved that colour issue. I'm not going to comment at this point on which pins were which, but this is part of the LD2 coal circuit. I'll pop the schematic up on the screen momentarily just to highlight what that does as part of the circuit. But now that is that board on test. Well, with a repaired picture and all I need to do now is get the sound sorted out on it. Now I have my test rig here, and I've changed the harness very slightly. So if I put let's see, so if I go over here and I find a ground peg, which is that one, and I do say start 1 over here, if I just tap start, where is it, start 1, come on, you're around here somewhere, let's test, start 2, slam, coin L, coin R, odd 1, odd 2, I like start 1, there we go, start 1. There you go, you can see the game's now playing, but no sound whatsoever. And I would expect sound at this point. Go on. Yeah, I'd be expecting to hear sound. I think I've got this loomed up correctly for the audio. It's a little bit weird because it basically has an audio circuit. It comes out of an LM324, and both parts seem to just... There doesn't seem to be an actual natural ground return on it, which is what confuses the heck out of me with this particular circuit. So, not sure on the sound. I'm going to go grab my board out of my other machine because there is an issue with that, and I might as well see if I can fix it at the same time. It doesn't always start up exactly as it should do. So I'm going to use the two boards to compare with each other. For those that are interested, there's the schematic part that has the L6 prom involved in it there, which receives signals from Mad Cell, Mushroom, buffer address 1, 0, 1 and 2, and then spits out enable lines basically. So right pulse enable, WP, I haven't got the part of the thing that's, oh here we go, WP, right enable pulses. So that basically tells it where it can and can't write to the DRAMs. If it's not writing to the DRAMs, which are this bit over here, the eight different RAM chips, if it's not writing correctly into there, then you're going to get bad colours coming out and all sorts of things. So no wonder we were getting that. It's not always in the circuit you might think. Now that WP line is not a direct read-write for data to go to and from, because if you're thinking, oh hang on a minute, aren't those ROMs serviced also by the CPU? Yes they are, they use partially a scratch RAM and things like that, but you've got 2 or 3 circuits affecting those RAMs, and that's why it turned out in the end to be that that L6 prom. Okay, well, anyway, that's just a bit of info on that piece of it for you, piece of the puzzle, and that's at least we've got that fixed now. I'm sort of investigating the sound section in a minute, see what's going on in there. I've got a 12 volt high drive on the scope, so I'm not sure what's going on. I would expect to see some sound coming out of something on the AUD 1 and 2 pins. So it could be that the LM324, which is the end stage of the sound, isn't quite right. I might get my pulser out in a second and see if I can inject some signals into it, see what happens. Right, I've got the logic pulser hooked up, which is a technique you'll not have seen me done yet. I've done this on the Moon Patrol video, which I haven't been able to release yet, just purely down to the fact that of the content that's in it, and it's taking so long for me to edit. So if I now go on here, I can inject a pulse. It's difficult to see on the scope, so if I can turn the volume down there. The problem is that it's attenuated, is this signal. So if I pull that on the scope there, if I pull down the there we go, back to 0. Well, that'll do. So it's a small enough scope screen that you can see, and I go and inject. You should have, in theory. Oh, it moves down at least. That's a good sign. That's a good sign. Let's give us a little bit more variance. What's that on? That's on 10. Yeah, it's on 10x, which is what it should be on. You can see it moving there as it. So let's see if we can zoom out a little bit more. So you might actually see a square wave going on, which is what I'm trying to get you to be able to see. There you go. There you go, there's a square wave. or part of a square wave. It's been attenuated by a 12 volt source. There you go. So I have sound coming out both speakers, which means I've now got the loom on the rig set up correctly. I'm going to go get my board and then see if I've definitely got this sorted, but I suspect that when I start working my way back through the chain, I'm probably going to find that this LM324 here, which is another quite common failure, is probably dead. Get the schematic part of it, which I think is sheet 2B, and we'll look at it from there. A little more debugging gone on the sound circuit, and I've been having a look around the pokey chip. So basically, here's the schematic for the sound. And the sound starts, if I work my way backwards, what I did is I've shown you that if I inject audio pulses here, I actually get something out my speaker, so I know that my harness is wired up correctly. So what I've done is I've worked my way back across this LM324 here, and I'm pretty convinced that this is the problem. I'll show you why. Pin 37 here on the pokey. The pokey, by the way, for all you know, stands for pot key, potentiometer and keyboard, and it's used for things like you can have dip switch inputs. It's also a random number generator and a few other little functions as well. It's actually a pretty cool chip. There's documents online in various places on how to figure out how to basically bend it to your will and whim, basically, and make sounds from it. What I've noticed was that I was seeing stuff coming out of pin 37, but I wasn't seeing it over here at pin 5. Now what I've done is I've replaced the 40 pin socket that was underneath that pokey chip, which was, well, pin 37 was falling off internally. I was able to sort of get a trace out of it, but it wasn't consistent enough, let's put it that way, for me to say, hey, that's a decent trace, that. So what I'm going to do now is I'm going to start the game off. I'm still not getting any sound, as you'll hear when I hit, let's do start 2, and there you go. So the game's now playing, but I've nothing. So let me find the scope probe, wherever I've just dumped that to. Here we go. And if I show you pin 37 on here, 39, 38, 37, that's that one. When missiles come down the screen, so in a second what you're going to see is it's going to hit the base at the bottom, and you're going to see pseudo sound on there. You're going to see something happen. There you go. So I've got audio output there. Now if I go across to pin 5, where it's supposed to go in on this LM324, which is there, and we watch the same thing. So look how I've got an identical line. I'm just waiting for missiles to come down the screen. So imports. Go on. I'll probably just fast forward this on the video. Cut to it. There's your thing, and it's about to crash into the thing. So I should say, there we go, we've got sound there. Now the output of that, so that's the input to that circuit. Pin 5, differentiated with pin 6, but should come out of pin 7, then be differentiated. Now I've checked that I've got voltages, plus 12 and minus 5 at pins 4 and 11, okay. So I'm going to go across now and show you pin 7. So that's pin 7 I'm attached to, which is at 12 volts, which is its reference voltage. That's perfectly correct. I'm waiting for a crash to happen. On the screen I'm seeing crashes, on there I'm seeing absolutely nothing. I wish I had two cameras to show you this in tandem to each other. I could have moved the scope and put it back to each other. But anyway, getting nothing out of this 324. I suspect now this 324 is dead. I've got voltages flowing into it, so I know it's nothing to do with traces. So I'm going to try and piggyback a 324 chip and see what happens. Let's grab one of those. 324 has got been piggybacked. I'm just watching the screen now, and I had a much more decisive pop when the game was powered on. This must be set in the easiest settings. There we go, explosions. Fantastic. That's exactly what, yep. Distortion is probably due to the two chips fighting it out with each other, and my speaker over here probably being a little bit on the loud side. So I'm going to replace that 324 chip, and hopefully that's going to be it. Now I do keep occasionally seeing some little bits of graphic glitches, so I'm still potentially going to have a few things to investigate on this board. And hopefully, there we go. Everybody should be dead. Oh no. Well, anyway, that's a good enough test to prove that the 324, that the LM324 chip, which is just basically an op amp in this circuit, you know, signalling here, nothing coming out here, pretty good chance that's dead. I mean, make sure you've got signals originating. If I hadn't got if I wasn't seeing signals here, I would have had to work my way back through the input chain to it and find out why, you know, an out 0 here, which is a trigger signal for it, and find out why it wasn't doing what it was supposed to be doing. So, I love this game. I'm absolutely rubbish at it, but I absolutely love it. The other thing I'm going to do as well whilst I'm at it is a bit preventative. Since I replaced one 40-pin socket here, there's another one over here which is the CPU. I'm going to replace that one as well because it seems to be somewhat flaky every now and again. There you go, there's your game over and the end sound. That's it. So now it's time to replace that 324. Okay, so something interesting's happened. So it's the next day now. It's Sunday, the 5th of July or something like that. And so I'm debugging this board a little bit more and trying to find that graphics glitch. And it was on and working. And suddenly I noticed a couple of times the screen was flickering, and then suddenly it just completely died off on me. So I can get it to and there's no VSync basically. So the game won't start now. If I put my scope probe on the VSync signal, you can see it's sort of trying to generate one, but it's not getting there. If I go over here to the HSync signal, which is that one, you can see I've got activity. So I've still got a horizontal pitch, which is why it's not scrolling all over the place, but vertically. Now a lot of things are tied to VBlank, which is like the interrupt and a whole bunch of other things like that. So without a VSync signal to go off every 50th of a second, it's not going to go. So I'm going to debug the HSync now. I just had a quick VSync signal. I just had a quick look at the schematic. I'm lucky enough to actually have a full printed schematic instead of just the on-screen one for this. I thought it was something to do with the ROMs and the RAM, so I did a Fluke test and everything, and no problems there. So what we've got is H8 apparently, pin 10. Pin 8, so which is an LSO8. So 1, 2, 3, 4, 5, 6, 7, 8. H, A, B, C, D, E. This should be H here, I think. That's J. K. H8 not populated on this version. Okay. I have to reinvestigate the schematic. Sorry, it was actually H7. So let's see if I can just do this live on scope. So here is H7. The output is a pin 8. That's what was. Am I probing the wrong one? Yeah. Pin 8 is there. Keep putting myself into 1x mode. I'm going to tape this scope up. There you go. So there's the VSync signal. There's pin 9. We've got a signal coming in there. And pin 10. We've got nothing. So I need to follow pin 10 back on the schematic and find out where that comes from, because I don't think that the H chip could be dead. I don't know what an LSO8 is off the top of my head. I'll have to look it up. Right, leave it with me. I'll be back in a sec. Okay, I've traced the VSync circuit back and it lands here basically at this S260. I've never heard of one of them, but basically it's a 5 input AND gate. I can show you that pins 1, 2, 3, 13 and 12 have all got what they should have. That's actually a grounded signal. It's got an inverter on it basically as this, so as the signal goes in it gets turned in, so that's a 1, and we know with an AND truth table that basically anything with a 1 comes out at where everything has to be 1 basically, and that's all correct. Well, that's the pin 5, which is the output, and you can see it's trying to float around and do things, but it's getting nowhere. So I'm going to have to scrat around now and see if I can find an S260. I'm probably going to pull one off the other board whilst I order some. Let's see if I can go and find a good one that I can use. Now S260 has been replaced now at A5, and guess what? We now have the game back running again. So I've still got this issue on the screen here where I've got bad colours on certain things. I'm just doing my head in now as to where the hell that is. So I'm going to start doing what I was on the verge of doing about an hour ago, which was trying to track down that. So I know it's not my VSYNC chain and my HSync chain and things like that. It's got to be something in the picture bit side. So I'm going to study the schematic a bit more and look for signals around things, but something's not quite counting right that's causing that. Oh, and just to be on the point, it isn't the PROM that's caused it, but the PROM that I had, I do think is bad, because with the other one in, it creates all sorts of streaks all over the display. And swapping it for another PROM that I've got, which I know is good, also for a moment that didn't do any favours to it as well. So I've definitely got some kind of problem in the picture chain somewhere that I just don't understand. So a little bit more looking at what's going on. I have a feeling that similar to why the bottom half of the screen wasn't working, I've got some kind of counting signal or a bit shifting signal that's not quite right. So I'm going to read the entire picture and DRAM addressing section of the schematic, because we're really close to a fix now. And we're back, and we've made some progress, and I think I've found the fault. Well, in fact I have actually found the fault, but I'm going to show you what the issue is. So the issue is this LS32 here at pin L5, which drives the WPX bus, which is the right pulse signals for the DRAMs. So the complicated way that this is done is, well, just complicated. It's not like other boards. This doesn't have a background layer, a sprite layer, a text layer and things like later boards did. Anyway, that's the signal I'm seeing. It's barely registering as a high signal, and every now and again you get a pulse that is high on it. Now this just doesn't look right. Now this comes off a LS00, which is, what's in the 00? That's an AND gate, is it? Up here at A8. And it's dragging the signal down, basically, as pin 10. So it's not the output pin to the WP circuit that's the problem. It's the input from the A8 chip over here that's the issue. Now, what I found was that signal there, so I thought, well, take a chance. Which one is it going to be? The comparator, funnily enough, said that this was okay, but the signal just didn't look right, and that's why it's taken me quite a while to track this one down. That signal's not right. If I show you up here, so let's say 1, 2, 3, 4, 5, 6, 7, 8. So this is A8, and I'll see if I can just get on to 16, 15, is that a 7? Yeah, it is. So 14, 13. There's pin 13, there's pin 12, and there's pin 11 output. So that is because it's been dragged low. Now, what I'll do now is I'll just pop the camera there for a second. What can you see me do? Right, grab that. I'm going to switch the board off. So I do all this in real time. I've already pulled and socketed the chip to find out that which one the thing is. My chip tester, by the way, did actually say that that was a bad chip when I pulled it out. So I'll pop that back over here. I have, and next to here's an LS32 I prepared earlier, which I'm going to pop into there now. And then I'm going to put my probe ready onto pin 10 there, and I'm going to power up. And can you see straight away that the signal on the scope is much different? So the input pin was dragging it down, and if I go over here and point it at the screen, that's exactly what the Missiles Command game screen should actually look like, with the blue and all the rest of it in there. So there's not really a lot more that I can do here now on the bench. So the only thing left, let's just have one final check of the sound. So if I found a ground peg, which is that one, because I just have to ground the signal, and I hit start 2, yep, we have sound. So I'll just whack up the volume and everything. I suppose, come on, God, they're slow on this. I just need to set the dip switches, and then what I'll do is I'll go and give it a test in my cab. My nice Missile Command cabinet. There we go, so we got sound, 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 and it almost takes out all the bases in the first volley. But the main thing is, we've got sounds, we've got game. The only thing I can't test on the bench here is the trackball. I can test the switches if I wire them up to my harness, which, to be honest, I really should do. I should just add the extra 5 or 6 wires onto this harness for future testing. We'll come back to it. I can hit the buttons with the things there. So there you go. So it's now going to take out that last. Oh, this is player 2 start. Anyway, that's enough of that. Next step is I'm going to go throw this in the cab and test the trackball. Well, here it is booted up in my cab. Let's check it out. We know start 1 and 2 works. The things that we're worried about are 1, 2, 3. Yeah, all the base launches work. The trackball seems to work as well. So yeah, well, I'm dead. I can't play one-handed. But that's it. Game works, trackball works, inputs all work. The other thing that doesn't work on my cab is the test switch wiring doesn't quite work how it should do. So well, I'm dead. Right, that's the end of this video. If you like more of this sort of tech stuff, then please do hit the old subscribe button if you've just found us via a search, and if it's not your first time being with us, then do give it a good thumbs up, hit a comment below if you want to ask us any questions, or even if you just want to ask us some tech stuff about something else that we haven't already covered. Lots more videos to come soon, and some new changes on the channel. We've got a new presenter coming as well very shortly. More about that in the next video. Alright, until then, that's it, the end.